Hello, today we are talking about probability again, but this time we are focusing on Venn diagrams and tables as our two methods of displaying and organizing our probabilities. So these are two new methods. They look different than the tables from last time, and Venn diagrams are brand new. So this goes in section 5.2 of your textbook. Please look there for more examples as we go. So just to review, key point number 1, we've looked at this key point every single video this unit because it is the most important key point. The probability of any outcome is the proportion of times the outcome would occur in a very long series of repetitions. So this links to law of large numbers. It links to probability tables and Venn diagrams and simulations. This key point is super, super important. So like I said, we're going to look at other methods of modeling probability. And the first method is called a two-way table. So we've seen these tables before, but we're going to use them a little bit differently. So it says students in a college statistics class wanted to find out how common it is for young adults to have their ears pierced. They recorded data on two variables, gender and whether the student had a pierced ear, for all 178 people in the class. The two-way table below displays the data. So we see we have this two-way table. I have my gender in my rows and then my pierced ears in my columns. So we've actually seen these before in chapter 1 when we did conditional and marginal distributions, and we're going to be using those same ideas today. So suppose we choose a student from the class at random, find the probability that the student has pierced ears, is a male with pierced ears, or is a male or has pierced ears. So let's break down this table a little bit and go through each one. So if I want to break down this table a little bit more, let's just take a look at this. Let's do this 4 right here. This 4 is saying that there were 4 females who did not have pierced ears. So 4 out of my 178 were females without pierced ears. That's how I'm going to read this table. So that's review. I know we've talked about that before, but just to recap, let's take a look at question A. It says, what's the probability that a student has pierced ears? Well, if I'm looking for probabilities, let me define having pierced ears as event B. Let's just call that event B. So if I want to know the probability of B, that would be looking at everyone who has pierced ears, so everyone in the yes, I have pierced ears column, divided by the total number of people. So I would do 103 divided by 178, and that would give me 0.579 or 57.9%. So this would be my final answer. Like we said in class, we're really going to prefer this decimal notation because the more we do with probability, the more useful this is as opposed to a fraction or a percent. So that's it for part A. This is a review of marginal distributions, which we talked about in chapter 1. But now let's take a look at part B. Part B says, what's the probability the person is a male with pierced ears? Well, this time, I'm only looking at the overlap of male and pierced ears. This 19 is the number that I care about. So if I want to know what's the probability they're a male with pierced ears, well, if male, let's call that event A, and pierced ears, let's call that event B, the probability they're A and B, that would be my 19 out of 178, not 103. 178, and that would be 0.107 or 10.7%. So 0.107 or 10.7% of the people are males with pierced ears. Part C builds on what we talked about in class when we have this union of two things, or I have this or statement. So C says, what's the probability the person is a male or they have pierced ears? Well, if I'm looking at male or pierced ears, that means I need to look at all of the males and all the pierced ears. Well, if I think back to the formula we had in class, I would do the probability of a male, which we'll call event A, plus the probability of pierced ears, which we'll call event B, divided by the overlap that they're both, or they're a male and they have pierced ears. So what this formula looks like with numbers is I would do the probability of A. Well, A is that they're a male. There are 90 males out of the 178, so I would do 90 out of 178. Let me move this up a little bit. Plus the probability they have pierced ears, which we already said was 103 out of 178, divided by the overlap that they're a male and have pierced ears. Notice that all of my denominators are the same. In all of these, I'm dividing by the total, and I'm looking at the males out of the total, the pierced ears out of the total, and then my overlap out of the total. And when I do that math, I get 0.9775 or 0.978, which is 97.8%. Which makes sense because if I look, there's only a few people who are not in either of those categories, so it makes sense that this is a really big number. So key point 1, if the problem asks for and, then look at the overlap. If the problem asks for or, then add together all that apply. So this is a key point that built on what we talked about in class with this or statement, but now we're adding the idea of and in the overlap. So method 2 is making a Venn diagram. So we can model the outcome of two events, A and B, by making a Venn diagram. And you've made Venn diagrams before in maybe science or history or English, and we're going to make them in here too. So if we talk about Venn diagrams in terms of statistics, if I think about this entire circle, this is all event A. So if I know the probability of event A is some percent, that means the entire circle has to add to that percent. But this space in the yellow, or this kind of outside of the overlap, this is all stuff that can only happen in A, not in B, because we have that border for event B. The intersection, or this middle piece, this is the stuff that happens in A and B. So that's some probability. This is the overlap, we like to call it. And then if you're outside of the circle, you're in neither A or B. So if you're outside the circles but you're in the square, that's the event that neither A nor B occur. So we have a little bit of vocab and notation to talk about. If we talk about the intersection of two events, the intersection is the and. So the intersection of events A and B, and this symbol means and. Means that both A and B occur. So that would be this overlap like we just talked about, but I notate it with that little kind of N without the tail to it. So that's my intersection vocab. I also have a union vocab. The union refers to the or. So events A or B happen is called the union, and I notate union with a U. So the union is the event that A or B happens, so we can see A or B would be anything inside of my A or B circles. So all of this would be in the union, whereas in the and, that was only the overlap. So key point number 2, the intersection refers to the and we notate with the little n. Union is the or, and it gets a little u. So if I wanted to make a Venn diagram, because we're going to have to do this, we're going to have to put numbers in our Venn diagram. If I'm given a two-way table, we first need to choose what's event A and what's event B. Well, in the previous example, we said that being a male is event A and having your ears pierced is event B. So if I mark on my table A and B and I label my parts of the Venn diagram, well, the probability I'm in this overlap, or the probability I'm A and B, would be this number 19. 19 people are in A and B. 19 people are males with their ears pierced. Well, the probability that I'm in this B area without being an A, that means I have my ears pierced, but I'm not a male. And that would be the 84 people who are female, because yes, they have their ears pierced, but they're not in the male circle. They're over here and just having their ears pierced, not being a male. Well, then if I fill in the part A, that's only part A, not overlapping with B, well, that would be the people who are a male, but don't have their ears pierced or are not included in the event B. So that would be 71 people. Well, then the people who are on the outside, they're not a male and they don't have their ears pierced, so that would be the number 4 to represent those 4 females who didn't have their ears pierced. So numbers in Venn diagrams are great, but we really want to do probabilities in there too. So in order to find the probability or to find that proportion, I could do 71 out of 178, and I get 0.3988 or 0.40. So 40% of people are males without their ears pierced. The overlap of 19, we said 19 out of 178, that was about 11% or 10.6%. So I can put that right here. The probability they're just in B would be 84, out of 178, which would be 47%. And then the probability they're on the outside, or they're just in that 4, would be 0.02%. So the goal is that when I add all of these up, I add to 100% or I add to 1. And if I add up 40 with 10.6 with 47 with 2, I get 99.4%, which makes sense. I'm a little bit off just because I rounded some of these, but all of these percents and all of this square has to add to 1 because my sample space has to add to 1. So here's a graphic that I really like because it kind of puts everything in one page. So it shows we started off with this table of pierced ears and gender, and then we analyzed different probabilities within that table. And from that table, I then made my Venn diagram where I showed who just is a male with no ear piercings, who's a male and they have their ear piercings, who just has their ear pierced and is not a male, and then who are the females with no ear piercings. From my table and from my Venn diagram, then I can do this bottom part. And this bottom part, I want to make sure that you feel super comfortable with this. So read this, look over it over and over and over again. This gives us the Venn diagram, the table, and the symbols. So the symbols are super important because these are what you're going to see on the AP exam. So A and B is the intersection because they're male and they have their ear pierced. A and B complement means they don't have their ears pierced, or it's B complement, they're not in B. Inside circle B and outside circle A, that would be this 84, and that means they're a female or they're not male and they have their ears pierced. And then outside both circles would be the complement of both. So this is a big kind of way of displaying tables, Venn diagrams, symbols, and describing it in words. This is a super important slide. And that's a wrap. We use Venn diagrams and tables to model probabilities. Probability rules must be followed and are our one way of checking work. So once again, section 5.2, make sure you look back at that section, feel super comfortable and confident making Venn diagrams and analyzing tables. That's a wrap, and I'll see you next time.